In this lesson, we will be multiplying and dividing rational expressions. Let's start with the multiplication rule for fractions. Since rational expressions are basically fractions, the same rules that apply for regular multiplication of fractions will apply to multiplication for rational expressions. Remember that when you multiply two fractions together, that they do not require a common denominator, and the process is that you will multiply the two numerators together, in this case a times c, and then place that over the product of the two denominators, b times d. Because polynomial multiplication can become very involved, I recommend that you use factors to make simplifying easier. And so I'm going to show you what I mean by using factors to make problems more manageable. When you have a monomial, you will prime factor it, and when you have binomials or larger, you're going to use all the factoring techniques that we were using in previous lessons. So let's say, for example, that we want to multiply and simplify 10 over 21 times 15 over 4. Now, if we do the regular rule for this, we would multiply across the top and get 150, and then multiply across the bottom and get 84. Inside of those two numbers, I see a few common factors, and sometimes it's hard to figure out what they are with numbers that are so large like that. So rather than multiplying straight across, what I recommend that we do is we multiply, but we use factors. So in other words, I'm going to multiply 10 and 15, but I want to also factor them while I'm at that, doing that process. So 10 times 15, 10 breaks into 2 and 5. And then 15 breaks into 3 and 5, and we're multiplying those together. 21 times 4. 21 is 3 times 7, and then 4 is 2 times 2. So what I really have is the factors of 150 on top. 150 is 2 times 5 times 3 times 5, and then 84 is 3 times 7 times 2 times 2. And you can see that it's a lot easier to identify where the common factors are. I can see these common 2's here divide for 1. These 3's divide out for 1, and that looks like about all. 1 times 5 times 1 times 5 will leave me with 25, and then in the bottom I'm going to end up with 14. And I do not have any more common factors because 5 times 5 on the top and 2 times 7 on the bottom means there aren't any factors in common. You can see in the second one why it would be complicated to say 12x times x squared minus 4 and then try to simplify it that way. It's a little easier to work with the factors in multiplication. So I am going to multiply 12x and x squared minus 4, but I'm going to factor them. 12x. 12 is 2 times 6, but 6 is 2 times 3, and then it has an x as well. X squared minus 4 is a difference of two squares, so I'm going to factor that using my difference of two squares factoring technique. X squared is x times x. You square 2 to get 4, and remember there's a minus and a plus on that, so that's the top part. In the bottom, x minus 2 does not factor apart, but it is going to multiply with whatever happens with 3x plus 6. 3x plus 6 has a common factor of 3, and I'm going to say the other factor would be x plus 2 when I factor that out. Now you don't have to do this, but I think I'll put a little dot right there. You can kind of see the factors, x minus 2, 3, and x plus 2 in the denominator. Now I can go through and divide out common factors. I see an x minus 2 divides by itself for 1, x plus 2 divides by itself for 1, and 3 divides into itself for 1. And this leaves me with 2 times x, which is 4x as my final answer. As I look to the third example, it's the same idea. We're going to multiply, but I'm going to go ahead and see if I can factor. So x squared plus 2x plus 4 is kind of interesting because it doesn't really factor apart. If you were to do the factor pairs, remember you have to have factor pairs at work, 1 and 4, 2 and 2. You aren't going to have a factor pair that adds to 2 in the middle. What that means is x squared plus 2x plus 4 is its own factor. 5y, on the other hand, breaks into 5 and y, so I broke that apart. Here in the bottom we have y, and now let's see what happens with x cubed minus 8. X cubed minus 8 looks like a difference of 2 cubes to me, and remember how this works. You're going to set up the cubes. What do we cube to get 8? 2. And remember how it's a binomial? and a trinomial. So let's see. We'll get x minus 2 in the binomial. Remember that all comes from here. And then the trinomial, x times itself is x squared. X times 2 is 2x. 2 times 2 is 4. These signs are always opposite, so minus plus, and then this is always a plus. Notice this. I actually end up with a common trinomial factor. X squared plus 2x plus 4 in the top is the same thing as x squared plus 2x plus 4 in the bottom. So this trinomial divides out as a factor for 1. And I also see these y's dividing out. So this leaves me then with a final answer of 5 over x minus 2. So let's take a look now at some division problems. From basic division of fractions, we can use that idea to divide rational expressions as well. When two fractions divide, we rewrite the problem by multiplying by the reciprocal of the second fraction. And so we'll do the same thing as we're working with rational expressions. So in our first case here, I'm going to rewrite this. I've got x plus 3 to the second power over 7, and then times 10 over 5x plus 15. Notice I have multiplication now. So I can do what I did in the previous problems to simplify these. So I'm going to multiply the square of x plus 3 and 10 together, but I'm going to write in factored form. So x plus 3 to the second power is really x plus 3 times x plus 3. And then 10 is really 2 and 5 multiplying. So you can see I have 1, 2, 3, 4 factors in the top. In the bottom I have 7 multiplying with 5x plus 15 has a greatest common factor of 5. And then I'm going to get x plus 3 there. So I have 3 factors in the denominator. So now I can divide out. I have a common factor of x plus 3, and I have a common factor of 5. What I see in the numerator is 2 multiplying with x plus 3 and then over 7. Sometimes this is fine, or if you want, you can distribute back out the 2 with the x and the 3, so 2x plus 6 over 7. Those are both acceptable to me. I think it's really whatever your preference is. Okay, so in this other example, we have, again, starting with division. I want to rewrite my problem into multiplication of the reciprocal. 5 over x squared plus 3x minus 10 times x minus 2 over x plus 3. Then I'm going to factor where possible and multiply. 5 does not break apart, neither does x minus 2. Now in the bottom we have a trinomial that starts with a 1. So I'm going to get 1 times negative 10 is negative 10. And it looks to me that negative 2 and 5 would be the factor pair. Since this is a trinomial starting with a 1, I can use my factor pair shortcut. X squared is x and x, and then I have a minus 2 plus 5. And that trinomial is multiplying with x plus 3. And then if we want, we can put a little dot here, though you don't need to. And x minus 2 divides by itself for 1. And this 5 on top is not the same thing as the 5 on the bottom. The 5 on the bottom is a term that belongs to a binomial. The 5 on top is its own factor, so those cannot divide out. So the top remains a 5, and the bottom goes to x plus 5 times x plus 3. And this should be fine. If you want, you could fully distribute out the bottom. After you do that, you get x times x is x squared. X times 3 is 3x. 5 times x is 5x. That's going to go to 8x total. And then 5 times 3 is 15. An alternative way to write the same. So you can see here that division, the process itself is rather similar to basic fractions. But I like to use factoring instead of going to large multiplication or products. I just find it easier.